The reason we spent some time during class today learning how to take square roots, simplifying square roots without a calculator, is that we're going to solve quadratic equations by taking square roots. So there's two different forms, basic forms that you'll get these into, one of which is given in these two examples. The other form will be given in the next two examples, and then we'll be practicing those for the next day or so. So if we take a look here, 2x squared plus 1 equals 17. If this was the equation 2x plus 1 equals 17, I have full confidence that we would all know to subtract 1, divide by 2, and have our answer. In this case, we have 2x squared plus 1 equals 17. Same first two steps. The inverse of adding 1 is subtracting 1. We'll do that. We'll get 2x squared equals 16. And then divide by 2. We get x squared equals 8. At this point, we have x squared. We need it to be x. Well, the inverse of squaring something is taking the square root of that something. So I'm going to take the square root of both sides. So we'll get x is equal to the square root of 4 times 2. I just wrote 8 as 4 times 2. We get x equals that. We need to simplify our answer, though. The square root of 4 times 2 can be rewritten as the square root of 4 times the square root of 2. However, the square root of 4 is something that we know. It is plus or minus 2, and we're left with root of 2. That would be our final answer. X equals plus or minus, positive or negative, 2 square roots of 2. So we have the same first two steps, and then we have to simplify a square root. That's the only new thing that we learned there. So if we take a look at the next example, 2x squared plus 5 equals 41. Again, if this was 2x plus 5 equals 41, I have no doubt that you guys would tell me to subtract 5 and divide by 2. We'll do the same thing here. Subtract 5. 2x squared equals 36. Divide by 2. X squared equals 18. Okay. Now we take the square root of both sides, so the inverse of squaring something. The x in this case is taking the square root. So we get x is equal to the square root. The greatest perfect square factor of 18 is 9. 9 times 2 is 18. So we would need to simplify this. We can rewrite it as the square root of 9 times the square root of 2. The square root of 9 is positive or negative 3. And we are left with the square root of 2. So if we take a look at these two examples, the first two steps are what we would do intuitively if it wasn't an x squared. So that's nothing new that we've learned there. The only new part is the inverse of taking a square of something is taking the square root. So when we have x squared, we square root both sides, and then that is where the simplifying square roots without a calculator skills come into play. That's how we would do problems that have 2x squared plus 1 equals 17, that are in that form. We have one more form. If you notice, these have parentheses, so they do stand out in that they're different in that case. What we need to do to solve these is to get the parentheses squared term by itself. So if we look in the first one, I have 1/3 times that quantity x plus 5 squared equals 7. In this case, I will multiply both sides by 3 to get rid of the 1/3. I get x plus 5 squared equals 21. Well, now we have something squared equals a constant. In this case, the inverse of squaring something is taking the square root of that very same thing. So the square root of x plus 5 squared is just x plus 5. Now 21, does it have any perfect square factors? Let's go through a perfect square. 1, we discard 1. 4 is not a factor of 21. 9 is not a factor of 21. And 16 is not a factor of 21. So we'll simply write plus or minus the square root of 21. Can't simplify it any further because it has no perfect square factors. That makes our last step relatively straightforward. Subtract 5 from both sides. We end up with x is equal to negative 5 plus or minus the square root of 21. Final answer. Okay. If we look at the second example here, somewhat the same process, except instead of multiplying by 8 here, we're going to need to divide by 8 because that's the inverse of multiplication. Divide both sides by 8. I get x plus 4, quantity squared, equals 9 over 8. At this point, we have the parentheses squared. We need to take the square root of both sides. That leaves us x plus 4 equals the square root of 9 over the square root of 4 times the square root of 2. I just in the process of simplifying the square root of 9 over 8. So if we look at the square root of 9 over the square root of 4 times the square root of 2. We simplify this as much as possible. We have 3 over 2 roots of 2. As we learned in class today, we cannot have a radical in the denominator, so we would need to multiply the top and the bottom by the square root of 2 over the square root of 2. That makes the numerator 3 roots of 2 over. I have 2 times square root of 2 times the square root of 2 is 2. That gives me 3 roots of 2 all over 4. So that means x plus 4 equals that 3 roots of 2 all over 4. That is plus or minus 3 roots of 2. Subtract 4 from both sides. X equals negative 4 plus or minus 3 roots of 2 all over 4. Final answer. This may seem daunting right now. I think once we do some practice in class tomorrow, you'll be more comfortable, and then even after one more day, we'll be in great shape. So come with your questions. We'll see you tomorrow.